Hello, what's up? Welcome to the first video of our channel, The Newtonian. In here, you will learn a lot about interesting topics about physics. So, in this video, we will learn about the second law of Newton. I find this topic really interesting because it's easy to apply to real life situations. So, the second law of Newton states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So in here we can also see the formula, which is force equal mass times acceleration. In the second law of Newton formula, we can explain that F refers to net force, which is measured in newtons. M stands for mass, which is measured in kilograms. A stands for acceleration, which is measured in meters per second squared. Some things that we learn about this law is that it tells us how the velocity of an object changes when it's subjected to a force. The greater the force, the greater the acceleration. The greater the mass, the less the acceleration for the same force. Also, an object with more mass requires more force to accelerate. This is why pushing a car is harder than pushing a bicycle. Also, direction matters. The acceleration produced is in the same direction as the net force applied. This is why direction is important in force calculations. So, we also have some real-life applications, such as the car crashes, in which seat belts and airbags are designed using this law. Also, we have sports. Kicking a ball relies more force, this being equal more acceleration. Also, second law of Newton is a vector law, and for being a vector law it requires, meaning they have a magnitude and direction. Also, a cool fact about this law is that it is one of the cornerstones of classical mechanics and is used to describe most of physical systems that involve motion. So, we have this exercise about the second law of Newton, which is a cart of mass 2 kilograms is placed on a frictionless horizontal track. A constant horizontal force of 6 newtons is applied to the cart. So, we have the formula, which is force equal mass times acceleration. And we take the data, and the data that they give us is mass, which is equal to kilograms, and force, which is equal 6 newtons. So, and we're missing acceleration. And we will use the variation of the formula, which is A, which stands for acceleration, equal F force over mass. So now we have placed the values into the formula, and our result is 3 meters per second square. With this result, we answered the question that the acceleration of the car is 3 meters per second square.